All right, 2016 AIME 1, question 14. Thankfully, more reasonable question, I think, than some of the other ones. Center at each lattice point in the coordinate plane are a circle of radius 1 over 10 and a square with side lengths 1 over 5, whose sides are parallel to the coordinate axis, or axes. The line segment from 0, 0 to 1001, 429 intersects M of the squares and n of the circles. Find m plus n. So the first thing that I did when I saw this is said, okay, I'm going to have a slope going through here, and I hope that it reduces. And so I considered my slope of 429 divided by 1001. And I looked at these and I first tried to just reduce this the normal way by starting with low numbers and see if anything's in common. And I do see that 3 divides 429, but not 1001. And then I said, okay, that's probably not the smartest way. Let me just factor these. So I broke down 429, and I broke down 1001 into the prime factorization. I do see that 3 is a factor of 429, because 4 plus 2 is 6, plus 9 is 15. If you add the digits, they're divisible by 3. Then the original number is divisible by 3. So I took out a 3. 4 divided by 3 is 1, 12 divided by 3 is 4, 9 divided by 3 is 3. So I get 3 times 1, 43. And then I looked here and said, okay, I know 3 doesn't divide 1001 because 1 plus 0 plus 0 plus 1 is 2. 5 clearly doesn't as well, but let me try 7. So I tried 7. 7 goes into 10 one time, bring down the 3. 7 goes into 30. 4 times 30 minus 28 is 2. 7 goes into 21 3 times. So this factors as 7 and 143. So I was probably in any reasonable estimation of the time it would take me to reduce this by trying to find the common factor first. I wasn't going to get to 143 before time would have been up on the test. But by factoring down both of them separately, now I see that, 3 times 143 divided by 7 times 143 is 3/7. Now, what that means for us, so we're looking at the lattice points. In here, we have a grid. Let me make a little grid for us. So I'm going to make it relatively small. And every time I go over 1 unit, I go up 3/7. So let me try to break this into sevenths. 1, 2, 3, 4, 5, 6, and then the 7th is up there. So 1, 2, 3, 4, 5, 6. And what actually happens is this. So what happens is this. We start at 0, 0. And every time I go over 1 unit, I go up 3 of these 7ths. And go over 1 more unit, go up 3 more 7ths. Go over 1 more unit, go up 3 more 7ths. And so if I look at a single spot in here, it's basically, so if I look at a single difference here, it's basically modular arithmetic where I'm doing, let's call it, let's do this, this will work. F of x sub, or f of x is equal to f of x minus 1 plus 3 mod 7. And so it's going to start 0, 3, 6, 2, 5, 1, 4, 0. So the next time it's going to hit is out here at 7, 3. That should not be surprising with a slope of 3/7. And in here, so looking at a single one of these steps, so I end up having a square with side length 1/5 And that's those might be a little bit larger than 1/5, but the idea is that means that they are 1/10 of the way into each of these, and we have 1, 2, 3, 4, 5, 6, and so as this is coming in, of course, if I hit the lattice point, I'm going to enter the square, and that works on both ends. Of course, if I'm sort of in the middle, well, it might not be of course. We'll check shortly why this is the case. But if I'm hitting this one of these middle couple of points, it's not going to intersect the square. But I have to check to see if these side points do hit the square. And the way I did that is, if the side length is 1/5, that means each of these is 1/10. I know that this distance here is 1/7. So what I can take is I can take negative 1/7, so I'll say I'm 1/7 below the lattice point, and add on the slope, which is 3/7, times the change in x to get past the square, which is 1/10, half of the 1/5, which would give me, this is going to be 3/70ths, so that would be negative 10/70ths plus 3/70ths, which is going to be negative 7/70, which is negative 1/10, which means it's going to just barely hit this. So if I come in and I'm hitting either the lattice points or any of these 1/7 or 6/7 points, I will barely hit the square. And since the circle is actually sort of the inscribed, or the circle inscribed in that square, it has radius 1/10, so it doesn't get all the way to the corners. It won't hit the circle for either of these. I have 3 out of every 7 of the lattice points that I'm passing through intersect squares. And only 1 out of every 7, not here, not here, not here, not here, not here, not here, but this one, intersect circles. And so if I go from 0, 0 up to here, I pass through, or go through, an additional 1001 of these, or 1001. So what I end up doing is I'll do these computations. I'll do 3/7 times 1001, and that's going to give me the m, almost, I'll talk about that in a second, plus 1/7 times 1001. And we already know 1001 divided by 7 is 143, and I have 4 of those, so I do 143 times 4. 2 carry the 1, 16, 17, carry the 1, 4, 5. But this only will deal with everything that I pass through. If I count this as the first and the second, we've forgotten to count this. And this will hit a square and hit a circle. So we will end up with a total then of 572 plus 2, 574 intersections of circles and of squares. If you have any questions, feel free to comment down below. And I'll get on to the last problem, which was another doozy.